Okay, this is part 3 of ECG and lab values. I'm going to go back to the basics because we need to know how to, in part 2, I did a lot of this and that. Jumped right into the examples of ectopy and arrhythmias with a focus on the tachyarrhythmias, which we're kind of focused on the highlighted for atrial fib, atrial, not flutter. I added that. So the final frontier lecture is focusing on atrial fibrillation, supraventricular tachycardia, and ventricular tachycardia as far as the tachyarrhythmias are concerned. Later on, we will focus on atrial premature beat, which is a PAC, and we will focus on premature ventricular contraction of PVC, and yeah, PVCs and VFib. So this is seems like we're focused mainly on no, there's a ventricular tachycardia. Yeah. So yeah, this one is just mainly focusing on the tachyarrhythmias in part 2. Part 3, we're going to go back to the basics and start with this video here, Introduction to ECGs and the Basics. In part 2, we reviewed the fact that we need to ask 6 questions when we are assessing ECGs in order to make a diagnosis. What is the rate? What is the regularity? Is the QRS complex narrow or wide? What is the atrial activity? What is the relationship of P to the QRS? Is the onset abrupt or gradual? And does the rate vary? And what are you doing? So let's go back to the basics of rate and rhythm. So what is the rate? And is that rhythm regular, irregular, and so forth? So we're going to start here.
Talk about what each of those waves actually means, and we're also going to look at a method of reading ECG. Hey everyone, this is an introductory lesson on ECG. So in this lesson we're going to talk about ECG paper and how it's laid out. We're also going to talk about the PQRST wave, talk about what each of those waves actually means, and we're also going to look at a method of reading ECGs and look at how we can determine heart rate, rhythm, axis, and intervals from an ECG. So to begin, we'll first look at ECG paper and how it's laid out. If we were to take a close-up look at ECG paper, we would see that ECG paper is made up of many small boxes that are grouped within larger boxes, and each of these larger boxes are a grouping of 5 by 5 of these smaller boxes. So the horizontal length of each of these large boxes is 0.2 seconds of time. So the horizontal axis of ECG paper denotes time. With regards to the vertical height of each of these large boxes, that actually denotes 5 millimeters. So the vertical axis of ECG paper denotes voltage of the particular wave you're looking at. So again, very important to recognize the horizontal axis denotes time, the vertical axis denotes voltage. So if we were to take an even closer look at each of these small boxes at a horizontal axis, or the horizontal area, each of these small boxes denotes 0.04 seconds of time. So 5 of these would again add up to 0.2 seconds. And the vertical height of each of these small boxes denotes 1 millimeter. So that's very important. That'll help you a lot if you can recognize that each of the small boxes vertically denotes 1 millimeter, because we use this number a lot to calculate if there's any left ventricular hypertrophy or left atrial enlargement, those types of things. So it's very important to know that. But it's also important to recognize that the horizontal axis denotes time and that each of these boxes represents 0.04 seconds of time, because we're going to use this a lot as well to calculate and make sure that, say, the PR interval is not prolonged, those types of things. So it's important to use when we're looking at intervals. We're going to talk a bit more about that later. So we're next going to move on to the PQRS-T wave. So if you haven't already, commit this to memory. first, it's pretty easy because it's alphabetical, but think about it again. So we'll go through this again together. We have the P wave first. We have a downward Q wave, an upward R wave, a downward S wave, and then generally an upward T wave. So again, commit this to memory if you haven't already. The P wave denotes atrial depolarization. That's what the P wave means. That's what actually happens with regards to the P wave. The QRS complex denotes ventricular depolarization. And the T wave generally denotes ventricular repolarization. Now, in some cases, you may see a U wave, and that is thought to be due to Purkinje fiber repolarization. You're not going to always see this, but I just thought I would add this here for completion.
I had all the it just came on, and I couldn't do anything about it. I'm like, whoa, what just happened to my body? Because our body's covered.
Yep.
Now, each of these waves can be categorized or organized into intervals and segments. So one of the big ones we're going to talk about is the PR interval. The PR interval starts from the beginning of the P wave to the beginning of the QRS wave, or the QRS complex. The QRS complex itself starts from the beginning of the Q wave to the end of the S wave. And the QT interval starts from the beginning of the Q wave to the end of the T wave. So these are the three I want you to remember. There are also PR segment from the end of the P wave to the beginning of the QRS complex, and there's the ST segment, which goes from the end of the S wave to the beginning of the T wave. I don't want you to think about them too much right now. We're going to get into more detail later in later lessons, because ST segment is very important when we're looking at any signs of possibly an ST elevation, MI, those types of conditions. So they're very important, but we're not going to talk about them right now. So we're first going to talk about heart rate. So how can we determine heart rate from an ECG? So we're going to first just talk about the basics of heart rate. A normal heart rate is 60 to 100 beats per minute. Bradycardia is less than 60 beats per minute, and tachycardia is greater than 100 beats per minute. So how do we actually calculate a heart rate from an ECG reading? There are actually a few different methods, and method number one, which is looking at QRS complexes times 6, is probably the easiest method, and that gives us a rough estimate of beats per minute. The second method is taking 60, the number 60, and dividing it by the RR interval time. And then the third method is taking the number 300 and dividing it by how many number of large boxes there are between RR intervals. So 300 times the number of large boxes between each R wave will give us an estimate of heart rate as well. So here are a couple of examples. The first one is sinus bradycardia, and the second one is sinus tachycardia. So if we were to apply the first method to this ECG strip, we would see there's 1, 2, 3, 4, 5, 6 QRS complexes times 6 is 36 beats per minute. So that is sinus bradycardia. We can also do it on the sinus tachycardia. How many complexes do we see here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 times 6 is 120 beats per minute, so that is tachycardia. So you can see that's very simple, right? Now if we try to use some of these other methods, we'll just attempt, we can try method 3 here, 300 divided by number of large boxes between each RR interval. So if we were to take a look at the sinus bradycardia example, 1, 2, 3, 4, 5, 6, 7, 8, so approximately 8 large boxes. So if we were to take 300 divided by 8 is about 37.5. Well, we said we had 36 from our first method, so it's pretty close. And with regards to method 2, we can quickly do that as well. So we can go, this is just an approximation, 1, 2, 3, 4, 5, 6, 7, 8, approximately 8 large boxes. Each large box is approximately 0.2 seconds. So that's 1.6 seconds. So 60 divided by 1.6 comes to, again, 37.5 beats per minute. So they're all very similar. The first one we had was 36 beats per minute on this ECG strip, and the other two were 37.5, so very similar. Those are the three methods we can use to actually calculate a heart rate from an ECG strip. So now that we know how to calculate heart rate, how do we determine the rhythm? And I'm going to just talk about the basics with regards to rhythm, and we're going to talk about very complex rhythms in future lessons. But the first one that I want you to just think about, the first question when you're trying to determine rhythm is, does each QRS complex have a preceding P wave? That's a key question. If it's yes, it's a sinus rhythm. And then you can kind of distinguish it even more. If it's a heart rate greater than 100, it's sinus tachycardia. If it's a heart rate less than 60, it's sinus bradycardia. Any irregular rate with each QRS complex having a preceding P wave is a sinus arrhythmia. Other arrhythmias that we'll talk about in future lessons. So this is basically what all I want you to just get from this lesson is just, is it a sinus rhythm or is it not? The other rhythms we'll talk about in other lessons will include atrial fibrillation, atrial flutter, premature atrial contraction, premature ventricular contraction, and some others as well. The method for finding the axis or the mean vector of depolarization within the heart is the following. If we were to look at all the leads on an ECG, we'll see lead 1, 2, 3, AVL, AVR, AVF, we'll see precordial leads. What we want to do is we want to look at...
Hi,
Hi.
I'm Tara, and I love making love,
Oh my
but I need my
goodness.
period. If you get periods, you know
TMI.
Find the most positive QRS complex. So when you look at all of those leads on an ECG reading or ECG output, find the lead with the most positive QRS complex. Then find the second most positive QRS complex. So look for a lead that has a second most positive QRS complex. And then you want to look for a lead that has the most equiphasic QRS complex, which means that you see an R wave that's equally as positive as an S wave that's negative. So that may all sound very confusing to you, but we can use an even quicker way of determining, is the axis normal? If we look at lead 1 and 2 and they're both upright, they both have R waves that are both pointing upwards, that is a normal axis. And why is that? Well, because if the mean vector of depolarization of the heart is pointing in the direction it should be, from right upper to left lower, it should be pointing in this direction. And the two most positive leads with regards to this are lead 1 and lead 2. So they're going in the same direction as lead 1 and lead 2. They're both going to be upright. Now, if it's a leftward deviated axis, which means it's going counterclockwise, it's being pulled toward the left, we're going to see an upward lead 1, but a possibly downward lead 2. And why is that? Well, if the axis has been shifted upward, so if instead of it going down toward the lower left, it may be going to the side or maybe going even higher up. What that means is it's still going in the direction of lead 1, but now it's almost going in the opposite direction of lead 2. So when it goes in the opposite direction of lead 2, it's going to... Now we're going to talk about intervals. So we went through rate, rhythm, axis, and intervals. The last step here. The two big ones that I want you to take away are the PR interval that starts from the beginning of the P wave and ends at the beginning of the QRS complex. This should be and is normally 0.12 to 0.20 seconds in duration. This you should commit to memory. 0.12 to 0.20 seconds. If it's longer than this, we're going to talk about AV blocks, and we'll get into later lessons about this, but just try to remember this amount of time. And remember, each of those large boxes on an ECG paper is 0.20 seconds. So if it's larger than one of those large boxes, if the duration is larger than the horizontal length of one of those large boxes, then you know it's a prolonged PR interval. The next interval we're going to talk about is a QRS duration, and it generally should be some say less than 0.12 seconds, and others say anywhere from 0.07 to 0.10 seconds. So, but generally less than, think about less than 0.12 seconds. That should be a normal QRS duration. And we talk about QT interval, and it's a bit complex for beginner lesson on ECGs, but the QT interval, we've talked about it before, it is formally calculated by what we call the Bazet's formula. So QT calculated equals QT divided by the square root of an RR interval. So you really don't need to know that, but just remember that in males and females, the QT intervals are generally different. And in males, the normal QTC is less than or equal to 0.44 seconds. And in females, the normal QTC is less than or equal to 0.45 to 0.46 seconds. So these are, again, important with regards to certain medications. They can prolong the QT and other instances where we want to keep an eye on that as well. So now that we know the basic approach to reading ECG, rate, rhythm, axis, and intervals, we're going to take this information, we're going to use it to assess different disease conditions like left ventricular hypertrophy and right and left atrial enlargement, and see how all of these things can be affected in those conditions. So please check out my next lesson on those conditions. If you haven't already, please consider liking, subscribing, clicking the notification.
Okay, he's an okay teacher. He's okay. Not too impressed, but doesn't go into detail enough. Okay, so we just saw the video. I took some snips of the video. Big square, small square, 0.2 seconds for the big square. 0.04 seconds for the small square. Introduction, regular big distances between R and R. That's the R. So R to the R are equal. If the distances are equal, then you have a regular heartbeat. If the distances are irregular, then you have an irregular heartbeat. So distances between R and R are not equal. For the regular heartbeat, you take the heart rate is calculated by 300, which is a fixed number. That's how the number if you're using a whole strip, EKG strip, divided by the number of big squares between R and R. So 300, so between this R and this R is 4 squares, 1, 2, 3, 4. So you take 300 divided by 4, and their heart rate is 75. So this is the R to R rate, R to R calculation if the EKG strip is regular. So you just need to take 2 R's and you count the boxes in between the R's. With this example, there's 4. So you take 300, which is a fixed number, and you divide it by 4, and the heart rate is 75. For an irregular ECG, like this one right here, you notice that the distances between R to R is irregular. Different from this one to this one to this one. They're all 3 different. So you would take the 300 fixed number times 3 distances, and then the number of all big squares in the 3 distances. So you calculate how many big squares in between the 3 distances, which is 13 squares. So 300 times 3 divided by 13 is 69. So let's watch another video, and she's going to talk about the way to calculate heart rate with the 6-second rule.
Check those out. But in this video, I'm going to give you a quick tutorial on how to use the 6-second rule in counting a heart rate on an EKG. There's various techniques you can use, but I find that the 6-second rule is the easiest, especially if your rhythm is irregular. Now on an EKG strip, you have your rhythm, which are those squiggly lines and the QRS complex, and then behind that are little squares. Sometimes they're really hard to see, but they're very important whenever you're using the 6-second rule trying to count your atrial and ventricular rates, or you're counting your PR intervals or your QRS complex. So they're very important because they measure time. And behind me, I have a blown up version of what one of those large squares look like. You have a large square, and inside that large square, you have small squares. And each small square represents a little fraction of time. One small square represents 0.04 seconds of time. And whenever you count up for your 6-second rule, you'll be counting these large squares. So 30 large squares equals 6 seconds, because 5 small squares equals 0.20 seconds. So when you add up all these large squares, 30 of them, you get your 6 seconds. So what you're doing is you're looking at your strip, which I'll do an example behind me, and you're going to count either if you're counting for your atrial rate or your ventricular rate. If you're counting for your atrial rate, you're going to be looking at the P waves, because the P waves are where your atriums contract. That represents that. And you would count every P wave in between 30 of the large squares. To do ventricular rate, you're looking at your R waves. That is the huge spike on the EKG where the QRS complex is, and this is where your ventriculars, your ventricles, are depolarizing, meaning they're contracting. So you're going to count 30 large squares in between those R waves. So behind me, let me show you how to do that. So behind me, I have an EKG strip. It's a 6-second strip, and I have blown it up so I can show you how to calculate those 30 large squares. Typically on a little EKG strip, you'll see the squares, and sometimes they're hard to see, and you may need a magnifying glass if you don't have the best vision. But for teaching purposes, I've enlarged it and made it a little bit easier so you can see exactly what I'm talking about. Okay, behind me, we have this rhythm. And what you're going to do is you're going to count either your atrial or your ventricular rate. First, we'll start with our atrial rate. Remember, atrial rate is represented with your P waves because it represents atrial contraction. So we have a P wave here, 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 and here. So to use the 6-second rule, we're going to start right where the P wave is and start measuring the large squares and count till we get to 30 and stop. And see how many P waves are in between those 30 squares. So let's start counting. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So right here is where we'll stop. So we're going to measure from here to here. And how many P waves do we have in between that? We have 1, 2, 3, 4. So you will take that number and multiply it by 10. 4 times 10 is 40. So we have an atrial rate of 40, which is slow. It's sinus Brady because the normal atrial rate is 60 to 100. Now let's count our ventricular rate. And remember, to do that, you do your R waves. You have the QRS complex. So let's look at our R waves. We have an R wave here, 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 and here. Now, R wave started here, and we're going to start right here and start counting 30 large squares, and then we'll count how many R waves presented between those 30 squares and multiply that by 10. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So let's count how many R waves presented. There was 1, 2, 3, 4. 4 R waves, and you take that number and multiply it by 10. 4 times 10 is 40. So we have a ventricular rate of 40. So that is how you use the 6-second rule. Very simple. All you have to do is count and look for your large blocks. So that is how you calculate a heart rate using the 6-second rule. I hope you found this useful. Be sure to check out our other EKG videos and helping you interpret EKGs. And be sure to go to our website, registerednursern.com, for free NCLEX quizzes and EKG quizzes to help you in nursing school. Thank you so much.
Okay, so that's the 6-second rule. Okay, so